Hello everyone, welcome back to sprouTalkz. Today I have an informative video in store for you. In this video, we will explore everything about float data type in Python in detail. But before we dive into the main content, please make sure you hit the subscribe button and turn on the notification bell so you never miss an update from my channel. If you haven't seen previous videos where I have explained various important basic things which you should know before going ahead, you can go through them. The link for the same is given in the description. Also, share the videos with your friends because the much you'll share it, the more you'll gain it. Knowledge sharing is the key to success. In this video, we will explore the characteristics of floats, their operations, some useful functions, different ways to use floats, and some real-life examples to work with them effectively. In our last video, we saw that integers represent whole numbers without a fractional part. But when we want to store a number having decimal point, we can't do this using a variable which is of integer type. So here we need a float data type. For instance, you can have variables like pi with a value of 3.14159, temperature with a value of minus 98.6, or price with 19.19. Check the type of the variable. Print type pi. Print type pi. You will get type as a float. So the float data type represents numbers with decimal points. These numbers can be both integers and non-integers. It allows negative values as well. Here are some of the characteristics of float data type. Floats support decimal points, making them suitable for representing non-integer values. They provide a certain level of precision but have limitations due to finite computer storage. This point we'll see in detail in some time. Floats can also be expressed in scientific notation, such as 1.23 e to the power minus 4. For example, let's take a variable, say salary. Salary equal to 7.7 e to the power 4. Print salary, run, and you get 77000. So here e to the power 4 is nothing but 10 to the power 4. The benefit of scientific notation is you can store a large number in short form. Let me give you another example. Say salary equal to 7.7 e to the power 4. Here instead of 4, just write 240. Means what? 7.7 into 10 to the power 240. Can you guess what will be the value? Let's check. It is giving the large value. Let's increase the value to 300. It is still giving the value. Now increase it to 350. Now giving error. Cannot convert float infinity to integer. Now why it is happening? Actually, float has a maximum value, but it depends upon your computer system. So if it exceeds that particular size, then it will give error or can give infinity as an answer. This explains this point that they provide a certain level of precision but have limitations due to finite computer storage. Next point is you can store binary, octal or hexadecimal data in int data type. But in float, you cannot. It only allows to store decimal data. Please note it down. Float data type allows to store decimal data type only. Let's check it on VS Code. So here we'll take one variable, say binary underscore value equal to 0b1101. What is 0b here? It is the prefix for binary numbers 0p. So it tells the computer that number provided is binary type. Then let's take another variable octal underscore value. So the prefix for octal is 0o. Let's take one number 755. Our third variable is hexadecimal underscore value equal to 0x. That is the prefix for hexadecimal numbers. So 0xa7. Let's print them. Print binary values. Here binary value. Print octal values. Our variable is octal underscore value. Print hexadecimal values. Hexadecimal underscore value. Here you can see all are of integer type. Do you see any decimal point here? No, right? So let's run this and see the result. So it is perfectly working. Let's change these values to float. So I'm just adding here 0.01, here 0.5, 0.2. Let's try to print again. So here it is giving error. So it is not allowed in float data type. You cannot store binary, octal or hexadecimal data in float data type. Next, we'll see some of the operations on float. You can perform various mathematical operations on float, including addition, subtraction, multiplication, and division. Let's see some of the examples. Take one variable num1 equal to 24.56, num2 12.23. Let's perform addition. To store addition, we'll take one variable, say sum, equal to num1 plus num2. Print the result, print sum is, and variable is sum. The same way do it for subtraction, multiplication, and division. Sub equal to num1 minus num2. Print the result, subtraction is sub. Take another variable mult equal to num1 into num2. Print the result. Take one more variable for division, du equal to num1 divided by num2, and print the result. Run it and see the result. It's giving the correct values. Next, we'll see various functions related to float. First function is float x. So here x is the value that we want to convert into float. So float x converts a value x to a float if possible. I said if possible means that is the condition. Let's see. First we'll convert integers to floats. So let's take one variable, integer underscore value equal to 42. What is the type of this variable? It is int. As 42 is an integer value, Python has created int type integer underscore value variable. As we have already seen that in Python, there is no need to explicitly mention the type of a variable, whether it is int type or float type or string. Python is smart enough to decide the type of a variable looking at the data it is storing in. Now we want to convert integer underscore value variable into float. So we have one function available here called a float. So let's take a variable, say float underscore type, to store float value. Apply float function to the integer underscore value variable and print the result. Here, as you can see, the output is not just 42, it is 42.0, means it is a float type. Python has converted integer 42 into float 42, means 42.0. Next, we'll see converting a string to a float. So let's take one variable, str underscore value equal to, you need to provide it inside double quotes, so 3.14159. Another variable, float underscore from underscore str, to store the float value, equal to float. This is a function to convert str underscore value. In the result, print float underscore from underscore str. You can see the output as 3.14159. This is also giving a correct result. Next, we'll try to convert a non-numeric string to a float. So take a non-numeric string in a variable str underscore value equal to ABCD inside double quotes. In this variable float underscore from underscore string, we will store the float value, float str underscore value. Print it. So you can see that this is giving error. So we were trying to convert a non-numeric string to a float, and this will result in an error. If you remember, we had mentioned that float function converts a value to a float if possible. Means to convert a value to a float data type, you need to provide the value in numbers. It should be a numeric data. For non-numeric data, it gives an error. Next function we'll see here is round. Round x comma n. So it rounds x to n decimal places. Let's understand with the example. Value equal to 3.14159.256. Take another variable rounded underscore value equal to, apply the function round bracket value variable here that we want to convert, comma 2. So 2 represents number of places, means here round to 2 decimal. So round value 2 function rounds the value to the specified number of decimal places. Here in this case is 2. So you can see the result as 3.14. It has rounded to 2 decimal places. Next function is math.sil. It rounds the value to the nearest integer. So here you can see how is the function math.sil. What is math here? It is the module that we have to use. Okay, so we will discuss modules in detail afterwards. Right now you will have to write in your program import math. Think module as a library where we have collection of various functions. Okay, so sil is the function which is available in math module. Okay, so we have imported math. Then let's take one value equal to 4.3. Take another variable sil underscore value equal to math.sil function. We are applying math.sil function over this value variable. Print sil underscore value, and you can see output as, so math.sil function rounds the value up to the nearest integer greater than or equal to x. So in this example 4.3 rounded up to 5. It's a sil value, so it seals the value up to the nearest integer. Next function is math.floor. Opposite to sil, it rounds down to the nearest integer. Again import math, take a value equal to 4.9. So here we'll apply math.floor value, print it. As you can see, output is 4. So in this example 4.9 is rounded down to 4. So these are some of the useful functions for various numerical operations in Python, including data manipulation, formatting, and mathematical calculations. Next, we'll see different ways to use floats. So you can initialize float variables by assigning values directly. You can accept float input from users using the input function. You can convert other data types like strings or integers to floats using float function. Leverage floats in various mathematical calculations. So let's explore the different ways to use floats in Python with examples. First one is initialize float variables. So you can create float variables by assigning values directly. Here variable pi equal to 3.14159, temperature equal to 98.6, price equal to 19.99. In these examples, we directly assign float values to variables pi, temperature, and price. Next, accepting float input. So you can accept float input from users using input function. The variable user underscore input equal to apply input function to accept the value from user. So in double quotes, you give a message, enter a number. In another variable user underscore float, we want to store the float value. So apply float function to user underscore input. Print. So in this code, we prompt the user to enter a number, convert the user's input to a float using float function, and then print the result. Next is converting data types. You can convert other data types like strings or integers having numeric values to floats using float function. Quickly we'll see example. So take a variable str underscore value equal to, in double quotes, as we want to give it as a string 3.14159. In another variable, let's store the result equal to, apply float function to str underscore value, print the result. Next, we want to convert an integer to a float. So take one integer value, say 42. Convert it into float value, print the result. You get the float values. Next, use in mathematical calculations. Floats are primarily used in mathematical calculations where they can participate in various operations. Let's solve some practical examples to see this. So here we want to calculate circle area. Let's take a radius of 5.0 and value of pi equal to 3.14159. So we'll use radius of 5.0, and for mathematical precision we are using the commonly approximated value of pi, which is 3.14159. We calculate the area using the formula pi into radius square. So take a variable area equal to pi into radius square. Print the result. And you get the correct area here. Now let's see how we can work with user input and float conversion. So in this example, we will demonstrate how to enter by accepting input and performing a simple calculation. So we ask the user for a number using input. So user underscore input equal to apply input function to accept the value from the user, enter a float number. We want to just convert this to float. So applying float function, we can achieve that. Now we have taken a value from user. Let's perform a simple calculation. So we want to double the input. So we will take one variable result equal to user underscore float into 2 to double it. Print the result. Double of your number is and result. So these examples demonstrate the versatility of floats in Python, from initializing variables to accepting user input, converting data types, and performing mathematical calculations. So in this video, we have seen that the float data type in Python is essential for handling real numbers with decimal precision. It supports various operations and can be used in a wide range of applications. If you found this video helpful and informative, I encourage you to subscribe to my channel for more Python programming contents. Thank you for watching.